Hi, I am Dr. Eli Kolberg from Unlimited Robotics, and in this video I will talk about proof of the equivalent resistance value of parallel resistors. We will prove the equivalent resistance value of parallel resistors in two ways. First way, we know that 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over Rn. Since all the resistances are positive, then 1 over RT is greater than the reciprocal of any individual resistor. 1 over RT equals sigma, or the sum, of R over Ri, and I is the index that is changed from 1 to n. This is greater than 1 over R or I, over individual resistance. And since 1 over RT is greater than 1 over Ri, according to inequality rule, RT is less than Ri. The equivalent resistance will be smaller than every resistance of each resistor, including the smallest one. Second way of the proof is by induction. Let's mark the equivalent resistance of n resistors that are connected in parallel by RT and n in parentheses. We already know that 1 over RTn equals to 1 over R1 plus 1 over R2 plus 1 over Rn. First, we'll check the equivalent resistance for two resistors, where n equals to 2. 1 over RT2 equals 1 over R1 plus 1 over R2, which is equal to R1 plus R2 over R1 times R2. And from them, we can find that RT2 equals R1 times R2 divided by R1 plus R2. We will now divide both the numerator and denominator of last equation by R2. The equation is RT2 equals R1 times R2 divided by R1 plus R2. We divide it by R2 and get RT2 equals R1 divided by R2 divided by R1 divided by R2 plus 1. Again, RT2 equals R1 over R1 divided by R2 plus 1. Since the resistor values are positive, the denominator is greater than 1, and the right-hand side of the equation is smaller than R1. Hence, RT2 is smaller than R1. Similarly, we will now divide both the numerator and denominator of last equation by R1. The equation is RT2 equals R1 times R2 divided by R1 plus R2. We will divide the right-hand side by R1, both numerator and denominator, and we get that RT2 equals R2 over 1 plus R2 divided by R1. Since resistor values are positive, the denominator is greater than 1, and the right-hand side of the equation is smaller than R2, because it is R2 divided by something that is greater than 1. Hence, RT2 is smaller than R2. The equivalent resistance is smaller than R1 and also smaller than R2, so it is sure smaller than the smallest between them. Mathematically, it is written as RT2 is smaller than min or minimum between R1 and R2. Now we will assume that the expression RTn is smaller than the min of R1 until Rn is true for n resistors. Then we will prove its correctness for n plus 1 resistors. For n plus 1 resistors connected in parallel, 1 over RT n plus 1 equals to 1 over R1 plus 1 over Rn plus 1 over Rn plus 1. The first n terms in the right side are equal to 1 over Rtn, so altogether we get it is equal to R over Rtn plus 1 over Rn plus 1. So 1 over RTN plus 1 equals 1 over RTN plus R 1 over Rn plus 1. We can refer to it as two resistors connected in parallel with resistance of RTN and Rn plus 1. We will use the result that we got for two resistors. RTN plus 1 is less than min of RTN and Rn plus 1. Developing last equation gives Rtn plus 1 is less than minimum of Rn plus 1 and Rtn, which is the minimum between Rn plus 1 and minimum between R1 until Rn, but minimum of Rn plus 1 and minimum R1 Rn equals to min of Rn plus 1 R1 until Rn, which results in that Rtn plus 1 is less than minimum of R1 until Rn plus 1. We proved the correctness of the expression for n plus 1 resistors provided it is correct for n resistors. Since we proved that the expression is correct for n equals to 2, according to last equation, it is true for n equals 2 plus 1, which is 3. And if it is true for n equals 3, it is true for n equals 4, and so forth. In summary, we prove that with n resistors that are connected in parallel, the expression is true. Rtn is less than minimum between R1 to Rn. It means that the equivalent resistor value in a circuit of resistors that are connected in parallel is smaller than the smallest resistor in the circuit. Thank you for being with me. Hope to see you next one. Bye bye.